right, so we've already discussed series circuits. And series circuits had the electrons going through all the resistors. And we used Ohm's law, V equals IR, to calculate the currents involved and all that for each system. So a parallel circuit is a situation where the electrons are going here. We have a 2-volt battery plugged into a circuit. And when it gets to this point right here, you have 2 resistors, one of which is 5 ohms, and the second one is 10 ohms. And it turns out that because there's less resistance here, you're going to get more electrons going towards that small resistor as opposed to the electrons going to the bigger resistor. You've heard of the expression, take the path of least resistance. This is literally an example of it. So the current's going to split up here. Now the voltage push, the 2 volts, is actually going to be equally distributed between the two. We don't divide it. Is that we're going to get a 2-volt push here and a 2-volt push here. So that's a big difference here. So for parallel, V total equals V1 and 2. And what I mean by V1 and 2 is that it is the system of a parallel circuit that we call V1 and 2. And that is going to be equal to the voltage drop. Now remember, when we say voltage, we're actually measuring how much the voltage is going to drop going across this resistor, and that equals V2. Okay? So this is for parallel circuits. Now, like I said, you want to look at how it compares to series, go back and look at that. And plus, we're going to look at that in the combined circuit system as well. Okay? So, since the V total is 2 volts, then that means then that V1 and 2 system combined is 2 volts. V1 is going to be 2 volts. And V2 is going to be 2 volts. So, big difference right here. In the series circuit, the sum of the voltage across each resistor equals the total volts. Here, it's split evenly between the 2 parts of a parallel circuit. Okay? Now, because of that, we could calculate the current. So let's do V total, or no, I'm sorry, not V total, I total, which we can calculate from V total equals I total times R total. Oh, so we got to come up with R total here. So how are we going to do that? Well, we can't add them together because this is not a series. And it turns out that the mathematics for this gets a little different. So the total resistance is equal to the sum of the first resistor and the second resistor in reciprocal form. And then we add those together and take the reciprocal of that. Okay? So, if we do this, and we need a calculator to get through this part, because it's not just 2 anymore. So this is going to be equal to 5 to the negative 1 plus 10 to the negative 1, all to the negative 1 power. And I said, oh, wait a minute, if they're both negative 1, why do we flip them? Well, because the plus sign changes it. If that had a time sign, we would not have had to have done this. But the plus sign changes it tremendously. So we're going to have to work this out here. So 5 to the negative 1 plus 10 to the negative 1 to the negative 1 power. 3.33 ohms. So even though you have 2 resistors, in tandem together, they actually come out less than either one individually. Now we can figure out I total, because now we have V total and I total, or R total. the total voltage here is 2. We're trying to solve for the total current times the resistance, which is 3.33 ohms. So on my calculator, find I total, I'm going to take 2 volts over 3.33 ohms. So I'm going to calculate 2 divided by, I'll just punch in second answer. So I have to type all that stuff in. Oops. 2 divided by second answer. I get 0.600. And since we're looking for current, this is the total amps in the system. Okay? So, now what I'm going to do, I'm going to find I1 and I2. So I1 is to be found by taking V1 equals I1 times R1. So 2 volts equals I1 times R1, which we said is 5 ohms. Divide that out, and I1 equals 0.400 amps. And then do the same thing with I2. I2 is equal to, we can get rather from V2 equals I2 times R2. Or if I rewrite this, and that's probably the better way of doing this, I can divide by R2. This is going to be V2 over R2. So it's 2 volts over 10 amps. And that gives me 0.200 amps. Now that makes sense. Why? Why does that make sense? Well, not the numbers themselves, but the relationship of the 2 numbers makes sense. Because we know that we should get more here and less over here as far as electrons over the same time frame, which is what current is defined as. But if this is 0.4 amps and this is 0.2 amps, that relationship makes sense because this is half the resistance of this, so this is going to have twice the current as this. And another thing that we'll notice here, we said that the total current is 0.600 amps, and each one individually is 0.400 amps and 0.200 amps. So that means then that I total equals I1 plus I2. And if there is more, we'll keep adding on to that. So this is kind of like what it was for the resistance and the voltage drop for series. You just simply add them together. So let's take a look at another scenario. Now we can start putting in stuff that we're well aware of here. We know that V total equals V1 equals V2 equals V3. And so that means then that they're all going to be equal to 6 volts. That we know. We also know that I total is equal to I1 plus I2 plus I3. And we'll work on that in just a little bit. And we also know that the resistance has this weird formula where we have to take the reciprocals of each resistor, R-1 plus R-2. I'm sorry, getting a little ahead of myself. R1 to the -1 plus R2 to the -1 plus R3 to the -1. All added together and taken to the -1 power. So these are my equations here. We know this, there's no work done in that because we were told that's 6 volts. But we do have to calculate these next. The next one I would suggest is this. give us the value of this using Ohm's law, and give us the value of this. Okay? So, let's go ahead and do that. Let's find our total here. So this is going to be 300 to the negative 1, plus 500 to the negative 1, plus 1,000 to the negative 1, all to the negative 1 power. 300 negative 1, plus 500 to the negative 1, plus 1,000 to the negative 1, all to the negative 1 power. And you get 158 ohms. Okay? So, we know that this is going to be 158 ohms. Now we need to find the total current. And for that one, we're going to use Ohm's law. So V equals IR. So V total equals I total times R total. Or, I could rewrite this since I'm trying to find current. I total equals V total over R total. Plug in for V total, and we said that's 6 volts. R total is 158 ohms. So we divide 6 by 158, and we get 0.0380, rounded off to 3 sig figs, amps. So I'll put 0.0380 amps right there. So we already know the values of R1, R2, R3. We already know the values of V1, V2, and V3. So now we need to find the values of I1, I2, and I3. So I1 is equal to V1 over R1. V1 we said is 6 volts. R1 we said was, I think we said 300, right? Yeah, 300. Well, 300 ohms. And that's going to give us 0.0200 amps. So, I2 is equal to V2 over R2. V2 is still 6 volts. And now this is going to be 500 ohms for the second resistor. And that's going to equal 2.0120 amps. And I3 is equal to V3 over R3. This is going to be 6 volts again, over 1,000 ohms. And this is going to give us 0.006000 amps. Now, just to double check, we're going to go ahead and add up all 3 of these, round off to 3 sig figs, and it looks like it's going to be 0.0380 amps. And I believe that's what we had. Yep, 0.0380 amps. E18. So, that's how we do parallel circuits. Your homework or your practice problems is an attached sheet to the Google Classroom. Just download it and work on it. And have fun.